these next videos, we're going to look at how to solve trigonometric equations. Before we begin that though, I want to talk about how many solutions a trig function equation actually has. If we do not restrict the domain of sine, it goes on forever like this in both directions. And so what happens is you actually end up with a lot of solutions. So if I graph sine of x, which is this graph right here, and then I graph y equals 1/2, it's going to look something like this. So these intersection points here are the solutions to this equation of sine of x equals 1/2. If you were to set these equal to each other, you would get a solution here, 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 and so on. And so what happens is you end up with a lot of solutions. As you zoom out, you actually have an infinite amount of solutions if you keep looking, because it goes on forever. So what we need to do is we need to account for that by solving for this solution here, and then adding 2 pi, which is going to give us this solution. And if we subtract 2 pi, it's going to give us this solution. The same thing works with this point. If you add 2 pi, you're going to end up over here. And if you minus 2 pi, you're going to end up over here. Okay, so now we're actually going to move on to taking the notes. So 5.3, solving trig equations. So in example 1, I'm just going to give you an equation, and we're going to go ahead and solve it. So we have 2 tangent of x minus radical 3 equals tangent of x. Before we actually tackle this problem, I want to show you a very similar problem. 2x minus the square root of 3 is equal to x. If I asked you to solve this back in like algebra 1, this wouldn't be a problem. We would subtract x from both sides. So you would get x minus radical 3 is equal to 0. And then we would add radical 3 to both sides. So we would get x equals the square root of 3. And we would be done. It's very, very similar with trig equations. Instead of solving for x, we're going to solve for tangent of x. So we're going to try to get tangent of x all by itself. So following the same pattern, we're going to subtract tangent of x from both sides. So we're subtracting 1 tangent of x. And if you have 2 tangents and subtract 1 tangent, you get 1 tangent of x left, minus square root of 3 is equal to 0. And then the next step is to add radical 3 to both sides. So we get tangent of x is equal to radical 3. Now this looks like problems we've solved over and over again. What we need to do is figure out which x value is going to give us radical 3. Well, it's positive, so we know we're in quadrant 1, and our 3 points are either pi over 6, pi over 4, or pi over 3. We know for sure it's not pi over 4 because that would give us 1. So it's either pi over 3 or pi over 6. So what I'm going to do is I'm just going to test pi over 3. And the way I test it is I go tangent of pi over 3 is equal to. Now, tangent is equal to y over x. So at pi over 3, the y value is radical 3 over 2. And the x value is going to be 1/2. So then we get radical 3 over 2 times 2 over 1, which is just radical 3. And if you notice, that's what I wanted. So our x value is in fact pi over 3. Now, as I said before, we have an infinite amount of solutions because all of our trig functions repeat. And so what we have to do is we have to add something so we account for all of those. So tangent's period is pi. If you recall, the period of tangent of x is equal to pi. This means that every time you go pi distance, tangent will have the same output. So what we have to do is we have to add a pi times n, where n is in the integers. So again, this means the word in, and this fancy z means the word integers. So this means that the solutions are pi over 3 plus 1 pi, pi over 3 plus 2 pi, pi over 3 plus 3 pi, and so on. And we box that, and we're all done. 5 cosine of x equals 3 cosine of x plus radical 3. So what we do here is we're going to subtract 3 cosine. We minus 3 cosine. These are going to cancel. And we get 2 cosine is equal to radical 3. The next step is to divide both sides by 2. And we get cosine of x is equal to radical 3 over 2. So what we have to do is think where on the unit circle is cosine of x equal to the square root of 3 over 2. Well, it's equal to the square root of 3 over 2 at pi over 6 and at 11 pi over 6. So that's most of our solution. However, cosine repeats, and so we're going to get infinite solutions. So our answers are pi over 6 plus 2 pi n and 11 pi over 6 plus 2 pi n, where n is in the integers. This 2 pi right here is a result from the period of cosine. So because cosine repeats every 2 pi, that's why we put the 2 pi n. Alright, so now on your own, I want you to try to solve this one and see what you get. Do not forget to put the plus 2 pi n because it's sine of x. Alright, here we go. We're going to subtract 2 sine from both sides. And so we get, this is going to be 2 sine of x is equal to radical 2. And then we're going to divide both sides by 2. And we get this is sine of x is equal to radical 2 over 2. So then all we have to do now is figure out where is sine of x equal to radical 2 over 2. And we know that it's going to be pi over 4 and 3 pi over 4. So our final answers are going to be pi over 4 plus 2 pi n and 3 pi over 4 plus 2 pi n, where n is in the integers.